In this section, I will look at the OSI model. To understand networking, it pays to have an understanding of the OSI model, as parts of it are used in modern networking. The OSI model, or Open System Interconnection Model, is a network model designed back in the late 1970s. The model itself did not get adopted. However, references are still made to it in modern networking, especially to the names and the numbers in the model. You will find that most network technologies do not match exactly to the OSI model and do not provide an exact fit. However, it is useful when discussing any networking to reference it against the OSI model. The OSI model has 7 layers. Each layer communicates only with the layer above and below it. By doing this, you can change a layer without affecting other layers as long as the new layer is compatible with the adjacent layers. To understand the OSI model better, consider a manufacturing plant. Imagine the first step in the manufacturing plant is to make a part. The next step, put a protective coating on the part. After this, the part is put in a box. The box then has a shipping label placed on it. The important thing to consider is that each step of the manufacturing process works on the previous. For example, you could not apply the coating to the part if you had already placed the part in the box. The OSI model works the same. Each process or layer of the OSI model adds to the previous. The OSI model consists of 7 layers. Each layer handles a different part of network communication. The first is the application layer. This is where the Application Programming Interface, or APIs, are found. Applications call functions in the API to send network traffic. Next, you have the presentation layer. This layer converts the data inputted from the application into a form suitable for transmission over the network. The session layer controls communication between two applications. For example, the session layer may decide on the port used for communication. The transport layer ensures the data arrives in the same order it was sent and is not duplicated. The network layer determines the path used to transfer data across the network. The data link layer provides error checking and creates the packet to be sent over the network. Lastly, the physical layer sends the data over the network media to the other party. To remember the 7 layers of the OSI model, you may want to consider using a mnemonic. 2 popular ones are, all people seem to need data processing, and please do not tell salespeople anything. Take the first letter of each word to help you remember each layer name. A is for application, P is for presentation, S is for session, and so on. The second mnemonic works from the bottom up. For example, P is for physical, D is for data link, N is for network, and so on. To better understand how the OSI model works, consider this. If a computer wants to send a message to another computer on the network, it communicates with the application layer. The application layer communicates with the presentation layer. The communication goes all the way down to the physical layer. As the data goes down the layers, more information is added, such as packet headers and checksums. The data is then communicated across the network over the physical layer. The physical layer can check the checksum and pass the data up to the data link layer. As the data goes up the layers, more data is removed, such as packet headers. When the data gets to the top, all the headers and checksums have been removed, and the data is presented to the application in a way it can understand. As stated before, the OSI model in its entirety was never adopted. However, the layer names and the layer numbers are still used today. TCP/IP is divided into 4 layers and can be roughly mapped to the OSI model. To better understand why TCP is divided into 4 layers, it is a good idea to look at what happens at each layer. At the application layer, you have protocols such as HTTP, SMTP, DNS, and RIP. At the next layer, you have TCP and UDP. Using TCP, you have reliable transmission, that is, packets are guaranteed to be delivered and delivered in order. UDP uses unreliable transmission and does not guarantee delivery or order of delivery. At the Internet layer, you have the choice of IP version 4 or IP version 6. The final layer provides a link to your network media. As you can see, using layers allows you to add and remove protocols and services very easily. For example, you could add a new network card, for example, a token ring network card, to your computer, and as long as the new network card can communicate correctly to the layer above, nothing else needs to be changed. As you can see, using layers makes adding and subtracting hardware, protocols, and services easy. To put the OSI model in perspective, you will see a lot of literature that refers to a device as a Layer 2 device or Layer 3 device. Switches work on Layer 2 of the OSI model. If you consider this small network, the switch is able to decide, based on the destination packet, which device to send it to. For example, packets coming from the computer to the printer would be directed straight to the printer. Packets going to the server from the computer will not be seen by the printer. The switches look at the destination address or MAC address to determine where to send the packet. If you add another network separated by a wide area network, the Layer 2 switch will not be able to route traffic to this network. To route traffic between different networks, you need a Layer 3 device, for example, a router. The router will be able to route traffic between the two networks, as routing is a function of Layer 3 of the OSI model. You will see devices on the market called Layer 3 switches. Don't get confused by this. Remember, Layer 3 devices support routing. Simply put, a Layer 3 switch supports routing and switching. Layer 3 switches perform routing in hardware rather than software, so tend to be faster than routers at routing traffic between networks. Since Layer 3 switch logic is built into hardware, they lack some features of routers. Keep this in mind if you decide to deploy one on your network. And just remember this. Layer 2 devices perform local switching in a local network. Layer 3 devices support routing between networks. Devices such as firewalls can work on much higher levels of the OSI model. For example, a good firewall can work all the way up to the application level and detect threats in protocols like HTTP. If you see a device that says it works on a particular level of the OSI model, think what that level does, and that will tell you what the device does. For the exam, make sure you understand the basics of how the OSI model works.